So today we're going to talk about variance and standard deviations, but first we're going to review the box and whisker plot. I want to show you how to do it on a calculator here. So if you have a graphing calculator, you're going to go to Stat and Edit, and we want to get rid of the first line. So if you go up and hit Clear, do not hit Delete. If you hit Clear, and then we could type in all these numbers. All right, and then what you want to do is go to Stat, Calculate, and we're doing a one variable stat. Hit Enter a couple times, and then there's your answer. So this tells us right here that this is our mean. And if I arrow down now on my graphing calculator, it gives me all the stuff I need for my box and whisker plot. So it's telling me that my minimum value is 3, which we already knew. And then your quartile 1 right here is 23. Where's that lower quartile? And then my median is 37. My quartile 2 is 50. And then arrow down, and my max is 55. So if you have a graphing calculator, you can do all of it on there. And then you would just plot your numbers. So we have 3 up to 55. And then it'd be more like pretty far this way. So this is 50. And this is 37. And this is 23 right there. And so today we're going to talk about standard deviation and real world applications. And right here, this answer on your calculator, the 14.98, is your standard deviation. So that is the answer when we say what's your standard deviation. It's that number right there, 14.98. So box and whiskers help us see how spread out the data is using the median and quartiles. We can also do that with a mean, which is averages. And then we're going to be doing variance and standard deviation. So this is called a sigma here, and sigma squared. So this was your sigma. See that little circle, the sigma? That's why the sigma goes with standard deviation. To find mean, let's see. There's calculators to calculate these by hand, but we'll use Desmos scientific calculator to find them. So we have a shortcut to calculate the mean. So if you type mean, if you want to find the mean, you would type mean, parentheses, and type the list of data points inside of this parenthesis. If you want to do standard deviation, you're going to type STDEVP, and then inside the parentheses, put all your data points. For variance, we're going to do ANS squared to do it. So all this stuff can be done in Desmos and can also be done on the calculator for them. So if you wanted to do the mean here, we would do mean and then 6.9, 8.7. So you type this into your Desmos calculator, and it should come up with the correct answer. So I'm going to try to do that real quick and then show you guys my screen so you can see what it's going to look like if you have to do this. We said 6.9. So now if you can see, let me minimize this for a second because I want to be able to see my camera. There we go. Oh, I think it's upside down now. Let me turn it around for you guys. All right, okay, good. Now you can see it. So you see how I typed in 6.9, 8.7 right there, 6.9, and it tells me that my answer is 7.35. So that's what I'd put under my answer for a mean. So it tells me if I want to do standard deviation, I'm going to use the same data values right here, but instead I'm going to put STDEVP. That tells me my standard deviation. So it's 6. So that round to like 1.67. So 1.68, I mean. And then if I want to do, so that's the standard deviation. And if I want to do the variance, I need to do answer squared. So I need to do, it works. I've never done this before, so you guys are learning with me. Answer squared. Oh, that didn't work. So let me take this right here. I want to take this and I want to square it. Try that. So if I square that, yep, I get 2.81. So that works. So we put 2.81 would be our answer for that. So you guys see how I just typed that in there? Don't do that. Do this right here, what I did for it. See, I have this ST stuff with it. All right, back down to my paper now. So that's what I put down here. So my standard deviation and the variance are those. Then I want to know how many standard deviations using whole numbers from the mean do the values fall. See, first we have your mean. So your mean is the 7.35 here. So that gives my middle, 7.35. And then what I'm going to do is I'm going to do a standard deviation up and standard deviation down. So it's 1.68. So I'm going to add the 1.68 to that. So do 7.35 plus 1.68. So 9.03. And I'm going to do 1 minus it. So that's called one standard deviation within our mean, 5.67. 5.67. So then I look, do all my data values fall between 5.67 and 9.03? So the top does, so that's good, but the bottom does not. I have a 4.8. So I have to subtract another time. So this is minus, and that's 1. So now this is going to be minus and get 2. So now I'm going to subtract 1.68 again. And I get 3.99. We saw that on my calculator right there, 3.99. Now that number falls within that range. So you'd say it falls within 2 standard deviations. All right, so the length of Beethoven's 9 Symphonies is 37 minutes. Standard deviation is 12. So I got 37s in the middle, and these are 12. So I'm going to add 12, and I'm going to subtract 12 to get 1 standard deviation. So just do 37 plus your 12. And that's going to be your higher number here. And then you subtract it to get your other number down there. Okay, I'll push that for you guys to see. So that's called 1 standard deviation. That's 1 standard deviation, and that's 1 standard deviation. And so it says that the shortest symphony is 22 minutes and longest is 65. So we have not yet included the 22 and 65, so let's add it again. So I'm going to add 12 to the 49, so you can just hit like 12 plus 49. So that's 61. Now if you subtract 12, you're going to get 13. So we're good on the bottom part. So this is 2. So we've met the 22 mark, but I have not yet got to the 65. So this is 2. So I need to do it one more time right there. And so we get 73. And now it falls within it. So this is 3 standard deviations. So we would have to say within 3 standard deviations this time. Okay, so this one is 3 standard deviations. Right. On the back, we're talking about the normal distribution curve. So if data is good, we call it that it follows a bell-shaped curve. It's a bell curve. It's centered at your mean. So mean in statistics, when you guys do it, it's like a U-looking thing. And then we have our standard deviations, sigma. So what we do is we have our means in the middle, and we're going to add our standard deviations to figure out what these numbers are. So what happens is that this is 34%. So 34% of your data, if it's a bell-shaped curve, will always fall in this range. 34% falls here. And so that's why 68% of all data values fall within -1 standard deviations and +1 standard deviations. So then we do 2, and 2 tells you right here that's 95. So 95% falls within 2 standard deviations, and then 97.5% falls within 3 standard deviations. So what does that look like? So first, if I want to do this down here, so we have Algebra 2 scores are on the final. They're normally distributed. So our mean's 150, so that goes in the middle. Standard deviation of 15. So to get my next numbers, I'm going to add 15 each time over here. And I'm going to subtract 15 each time over here. So those are our numbers. So it says what percent of students took the scored between a 120 and a 150. So I need these 2 areas adding up. So if we back up here, this is 34 and 34. That's how you get 68. So this one right here is going to be 13.5% on each side. And then this one right here is 2.35%. And then this last area down there is 0.15%. And so if I need to add these two, I just add up 34. So I'm going to do 34 plus 13.5%. And that tells me that 47.5% of all answers fall in that range. Now it says if 250 students took the exam, approximately how many scored above 180? So first we need to figure out what percent is above 180. So we'd add up these two areas over here. So that's the 2.35 and the 0.15. So 2.35 and the 0.15 gives you 2.5. So that's a percent. So I'm going to change that to a decimal and multiply it by my total number. So 0.025 times 180. That gives me 6.25. So about 6 students scored got a 180 on it. All right, so our last one, to win a prize at the county fair, diameter of a tomato must be greater than 4 inches. Diameter of the crops. So it's normally distributed. So the mean is 3.2 and standard deviation is 0.4. So that means I'm going to put a 3.2 here, and I'm going to add 0.4 in each direction each time. So that's 3.6, 4.0, 4.4. And I'm going to subtract it now in this direction. So 2.8, 2.4, and 2.0. So it wants to know to win a prize, we got to have 4 inches and above. So that's this area right there. So what's the probability? You just add these two areas up. So remember that was a 2.35% and a 0.15%. So you have a 2.5% chance of being a winner.